Ladies and gentlemen, I don't know why my voice is so fucked currently. But yeah, but my voice is a little bit fucked today, so. Oh wait, what? Two things they fucking get 3 average viewers here yesterday? Holy shit! Holy shit! That's fucking good. Perhaps a partner soon. Holy shit. Yeah, alright. Put that one over there. I fucking spilled salt all over my fucking table. Right, don't mind if I like accidentally just like do this because of salt. Wouldn't think that would be salt. Apparently I wasn't salty enough. Yeah, please. I think that would be good. Okay. Let's just do this one. Oh, that was up. Yeah, a bit tired today. Gonna get this one. Let's see. Does this explode? Well and truly, it did not. Cheers, folks. Oh. All right. Okay. So today, I decided yesterday to do something probably a little bit stupid. Yeah, as I said before, yesterday I decided to do something halfway stupid. I can't just get that one window, but okay. I decided to do to try to get the. I don't know, this fucking music's too fucking loud. There. It may be good music, but it was damn also fucking loud. Let's see, was it in here? No, where the fuck was it in the G? No, it wasn't in the G drive. Wow, media? Abyss. It wasn't on the D drive. Where the fuck did I put it yesterday? Wasn't home? No, it wasn't in home. It's not in here. I moved it away from there. Am I missing a disc? Am I missing a partition? Yawn. Oh yeah, I do. I was missing a partition. For fuck's sake. I was goddamn missing a partition. No shit then that it didn't show up. But yeah, paging. All the following code was actually, maybe I should really quick do a reference there. Was it Lex? No, Lex was, it was not Lex. Or was it? Yeah, it was Lex. Yeah, paging. Original code. Alright. Yeah, it came from this dude's DevOS, which currently that is the only thing that I actually have found to be good. Media, Biz, eDrive, BSOS. There. No. Alright, but yeah. Yeah. So I decided to do some paging yesterday. Why the fuck is my camera up here? The camera should be down here. Currently, as you guys can see, probably it's not going really good. We have a lot of read errors, read-write errors. I found where it comes from. It has something to do with the IDT. The pit, yeah, the pit and IRQ and all that shit. All that office. So yeah. So because the IRQ and whatnot, it fucks up. Hello. I would guess that you have made some research about the GDT. I was okay, yeah, okay. You were stupid. Okay, let's see ya. Sorry, wait, what? Like, tell me, please. I can hardly even remember anything, but yeah. Like, was it? Yeah, it was about the GT and whatnot. I will also say I'm probably also not the best person to actually like explain things. So. I forgot that paging can work as a security feature. Oh yeah. I had actually totally forgotten about anything about paging. When we like last stream. Like I had also totally forgotten about paging there, so that's also fun. But you are definitely not the only one who did forget. Up there. That's good. Don't worry. But hey, talking about paging, now you get to see me bashing my head against the wall. Do you have page? No, I'm currently implementing it currently. Yeah. So currently this whole stream currently, the schedule on the stream currently is that you're going to see me bashing my head against the wall because flat mode is insecure without it for sure. Yeah, it is. But for me at least, paging hasn't worked for me. Like the OS like just loops, and now I get all these fun like read errors and whatnot. And I know where it comes from. At least I know where it comes from. Okay, grab onto it. Thank you. Yeah, a flat memory model is very much unsecure. Why the fuck do you get EC59F159? How the fuck do you get that address? 2 seconds, 2 seconds, 2 seconds, 2 seconds. What do I do here? We say the virtual address, run that over with 22 bytes. So that makes it smaller. Setting it there. Setting that one. Then setting the last page. But I'm not... Actually, yeah, I am mapping. Mapping that address. And that was in hex, right? Yeah, that's in hex. Like, that is in hex. Maybe I also should really quickly enable these two again. I always forget that I have these... I have my alerts and chat things here also. I always forget to enable them. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No, it doesn't actually fall within. I think no, it doesn't actually. Wait, what? I hate fucking paging. Should I actually do like have this like be translated over? Does this need to be translated from virtual to physical? Or is this physical? I hate fucking... I can try to... So here we just like map it. But wait, it should actually technically just... Yeah, it shouldn't... Should it? Like... It should just... translate automatically. Shouldn't it translate automatically? And why the fuck is there only one here? There should be two. I hate fucking paging. I hate them you. I'm not in. So I moved that one into there and there. 8001. Okay, that one means protection. Yeah. Four megabyte pages. 4 megabyte pages? You can fucking do 4 megabyte pages. Oh shit. I don't think I'm gonna need that. But thank you, I guess. Physical memory. The page table says 0 and 0 there. 2. So 1 to 2, I guess. And then 2. This one. To 1. And whatever the fuck else. And from... No, wait. No, that's to 0 from 3 to 1 from 5. Yeah, okay, Gucci. So we also probably need to do this. We should probably also have a get a physical address function. We already have mapping. Which we kind of already have this one. We kind of already have a get from the map. I'm fucking beginning to grow beard again. Damn. Alright, so we should have ourselves a void pointer. And we should say get physical address, the virtual address there. So we need to say the page. Actually, page table. We don't just have a. No, we don't just have the page table just lying around. We have the page directory, but not the page table. But the page table shouldn't be that hard to do. Hope. Yeah, it should. Can we just get it from the page directory? It's a page directory, page table. So how is this laid up? Yeah, so the page directory into an entry of a page table or into a entries. A few entries within the page table that then correlate to a 4K that then correlate to a 4K page. Effectively doing a whole lot of fucking things with my. So this should technically work to get a page to get a page table. We should probably also get this, the PT ID. So this is the PD ID. Page directory. PT there. Then we should do a. Then we should actually just have it. Shouldn't this then be the PT? Use the page table ID? No, it's that's because we already used that here. We get the offset there, and then get the offset within the page. Yes, okay, great. Have I said how much I hate fucking paging yet? IRQ pointer, get the physical and loss there, set that to be there, and let's then hope. I did do fucking hope. Bad question. Okay, so here you don't need them, but every single other place you do need to have fucking inlined. I hate fucking inlined assembly. Alright, so I should probably also read out the motherfucking the physical address also. Be wary, this is where the headbanging begins. The headbanging against the wall, that is. Alright. Alright, let's see. Okay, so that didn't do anything. What if I do both here? What if it has something to do with memory I/O? But there's nothing that's there. There's nothing like here. What if it actually like gets in, but then fucks up either way? I don't know. It just literally says reason rejected in no region. In a no man's land region. Because yeah, it gets through here. You can clearly see that here. Set there. Like, it could be as simple as just like as it just like being I think I found the solution. The reasoning. Like fully now the reasoning. So if I set some ASM int 2 ASM int 2, I think I found the solution. Let's see. If there's 2 breakpoints here, then I'm losing it. Yes! My fucking theory was correct. But wait, so since there isn't even one. Well, debug it is. Alright. We need to then take this one. Let's see. I need to get myself a better layout at some point. But for now, just throw myself over here. Yeah. You can't. Then you can see the files, but you don't need to see the files, and also not the half of all that. You don't need to see that, right? Lay next. Breakpoint on there and continue. There, we got it. We haven't gotten anything yet. Now we're gonna go line by line to check what's fucked up. So we are still in the now we want to set up the stack frame. We do that right here. That's the stack frame. Right there. We've set up the stack frame. Now we want to compare. If it's true, then we want to, I guess this is a way, get away from, yeah. Then we'll call the log f, clean that one up, log f, clean that one up, and then get physical address. Right now, clean that up too. Then we'll store it. Then we wanna set that down there. Here we actually set it. Here we call log f again, right there. Here we set it again. We call log f. We then compare int2. Something fucked up. Something actually fucked up. Holy shit. With int 2 here. For squid. And then just like is inlined. Like fully inlined. Whoa. Waiting for my terminal. This is that is actually like how fucking NeoVim sometimes start up. Like just that, right there. I guess you saw it, right? Like just zoom in for all the grannies over here. Oh damn it, that didn't work, damn it. I need to fucking fix all those errors. I guess this was lost. E drive, wasn't it E drive? It wasn't MNT, no, it was media. It was also BMBIS and then E drive and then OS clear sudo that there. Right there. And zoom in again for all the old people here. And people with the phones too. Okay, two things. I'm actually going to... Now that's chat. I can't just block chat. Chat is going to be moved very poorly up here. Is there a gap? There's a gap. Fuck that. I'll have to do it later when I actually get a real like real way to actually like move this one up here, but it doesn't block that much actually. Damn, my forehead is big then. You know what, we're going to debug just like that. Okay, what we have figured out from all that is, I don't actually fucking know. Lane, next, breakpoint on there, continue, and we'll do it. Why do I feel like this one is a little bit too close? Thank you. Now, here we are. And now we want to be on the lookout. Clean up. We now wanna... We push in 21. We then do out in B reading from port 21. We clean up. We move it over to EBX. Maybe I should actually have the assembly. No, wait, not the assembly view. Register and source view. So now you can see it here. Slide it over by a bit. We then not it, we do a whole bunch of other things. And now we store it right there. We then get it back. This is an optimization that I hate. Like you can optimize this. For fuck's sake, people, you can optimize this. You don't need to save it and then load it again into EAX. You don't need to do that. But anyways, clean it up again. clean fully up again. Push the value first, the port, out B, out B. There, we got it. We have found the fucking culprit in all my misery. We have found the culprit. Out B. Just like, we have found the culprit. Out B. Yep. I couldn't do that, okay. Next, next, next. Now, step in. Okay, so now we need to remember, what are the arguments? The arguments were 21 hex and whatever the fuck EAX was, which is FE. Can I see here? Set up the stack frame, push our two registers onto the stack, zero out EDX, move one of them in, move the port into DX, move the value into AL form. Now we don't know what is happening, but okay. Pop, pop, pop. Something fuck is happening to stack. Can I check print slash there API? Can't check registers. Or can I? Yes, I am walking around with a fucking reference card for GTB. So we can check the frame. We can check locals, arguments, registers. And is there something about the stack? We can backtrace, print trace of all the frames in stack or of n. Alright, so I guess BT. Right here. So what we should get, I think that this is how it's supposed to be. What we should get here is this value. This should be our reset, like return value. Now, any guesses what we will get? Wait, what? Damn, it was correct. Now, what? Why? So now we jump to some place. When I move, backtrack. Now and then return. Hopefully we should return to 1B6220. Actually, that was where we are currently to pit in it. We are in pit in it, yeah. Add ESP, subtract, do all of that. Log. It's log F. That doesn't make sense. That just doesn't make sense. Continue. there, NB. If I do here, then we fuck it up. So we should wait till here. Then we should do... wait, what now? Okay. So something fucked is either happening in out B, or right here. Which one of them I don't know. Why am I like, I'm just constantly getting like, I think I can remove the physical handler. I don't think I need that one. What if we just unmask everything immediately? Salt. Damn, I hate salt. It's because like I need to like fill up my salt jar, and of course how fucking like, why is the best place to fill up your salt jars? Of course right here on your table. I should still have some remnants of salt right here. Damn, I hate salt sometimes. Alright, so what if 2 seconds? I see this one. Yeah, we do have an unmask. What if we just unmask it immediately? Oh shit, I hate it. What if we just like do this, and then we and now we run it. What we should see, hopefully, I constantly just seem like the same address, initializing pit. Okay, so now you're fucking just like, now you're fucking up here on the sit pit. Why? I am actually beginning to be fucking irritated over all this. So we can mask, set mask, set mask. What do you do? It's probably better to just like do this one. Like actually something is fucked. And I'll bet that much to say that okay, a little bit of a thought experiment here. What if I decide to say we initialize the pit before we do memory allocation. Because now unhandle IRQ 0. Alright, but that's a different thing. I guess you could say. The things, do I actually have an unhandled like error? Wow. I should probably do this one first. And then we can think about doing everything else. Yeah, right now. So paging init successfully. Init devices. Now just stop there. At least we just stop and not get like a million errors. And I have a feeling either it's because of malloc. Cleared. So pretty much now what we're doing. Invalid read error. Init devices D. That address, that reminds me of something. Why the fuck have I seen that address before? F00 F000 F8EC. It's close to there. What if I do a pmalloc? Now you might ask, what the fuck does pmalloc do? Well, it uses a page. An actual page. Allocated from 0. Okay. New idea. Deep log f. There's something wrong with log f. Moving you over here. Init device. So focus CMD lay next twice. There. Okay, so if my count me in as being surprised. Alrighty. So it's this game. I stepped, for fuck's sake. I fucking stepped. I didn't go. Step instruction. Load effective address into EAX. Maybe I should really quickly have. Next and next. So now again the I can't remember what the fuck the address was, but yeah. Push, push. Alrighty. I remember that thing. I need to remember that thing. 0xC455A 517. And I step instruction. So there should be a at some point there should be a read error apparently to that address. Currently I don't see it anywhere. It's maybe in here. It's maybe EFS. This should just like out be okay. Okay. So right now, how I do this without being all that shit, I have these assembly functions here. What if instead of that I have to did that one wrong. So the end. Actually, two things. It is from home and to the end. SM. I guess that is it. Let's just do all the outs. Then value. There. Now we have true actual true motherfucking inline assembly for these ones. So should I? There's one thing I hate about VS Code, and that's that if you press upwards whilst having a multi-cursor, you don't go back. No, that would be too easy. No, that would be very much too easy. So now if I run this, no such instruction. Is out D as in an out D not instructions? x86 instruction out D in D. Out double output to port. Out SD. Okay. Oh, it would seem so. Because okay, I don't think out D is an instruction. If there's anyone out there that can actually like fact check if that's true or not, then please do. Oh yeah, there's linker errors. Yep. Out D. Really? Am I using Out D so many times? I do not. Here's what we do instead. We do Alt W. And this needs to be to the same port both the times. And for in, we do this. Technically still valid. Oh. Main. You just need that space. You literally only need that space. I'm not doing anything like. So paging successfully got good right there. Does this still do anything else? What is code? Paging enabled. Yeah. Interrupts were enabled, beware. Maybe I should. Don't I have an instruction for enabling, disabling interrupts? Yeah. This one was set interrupts. But don't I also do that here? Maybe it could be a good idea if I actually do it. Before paging, before enabling paging. Now, this one does stat panic enable interrupts. Yeah, STI. Okay. Something at least. Now it's to an address that I don't even know existed. Paging were initialized SU. Invalid write at address there. Region DMA. Wait 2 seconds. This is 0 hex D4. 0 hex 4. We have this one here. Where one means 3, right? But that's only for BIOS and whatnot. That's not for the rest of them. So we're allocating bytes there. Kernel heap starts there. 2, 3, 1, 2, 3, 4. Does that match? I think that matches. And then we map with directory entry at there. And enable, and then there, and we just ended SU. Just SU. Successfully. So if I should say anything, maybe, I mean, maybe on a timer before the first pick, like, interrupt goes off, maybe actually. Maybe it has something to do with the pick interrupt. Maybe actually, yeah. If I go in here, I just move this one forward to here. Okay. I think I found a culprit at least. The IRQ is maybe what fucks everything up. Which does actually also make sense. Because the IRQ doesn't... Yeah, that kind of... That makes kind of sense. In some way, shape or form. Now we do the pick and the keyboard. What if I do VDA first? Now it was right before initializing the pit. And if I start again, termination signal 2, add a pit again. Just the pits again, but right before with this configuration we could make it further. What if we enable interrupts here? What do we then say? Also right after doing initializing pit initializer. The pit says again, if we flip these two once more, initializing pit, then now that's the first thing that happens. So it has some, I guess it has something to do with this. So if I comment out initialize pit, what will then happen? Then we get something. Keyword, something. We get there. We get some stats there. That's not how it's supposed to be like. Oh, that's the fucking \n. So let's read those stats real quick. So a whole bunch of vendor IDs. Let's see, right here. So I need to move my screen. There you can see my back. The back. Should just in that could be an interesting stream. Okay, so memory used a few bytes, memory free a lot of bytes, heap size there, heap start, end, p heap start, and p heap end. Now p in p heap is the page heap pretty much. This is the normal heap, and the p heap is the p heap. So okay, so now it's in. So where are we now fucking up? Enter clear. So we're going in there. We should have printed kernel start, print memory region. There we got it, and PCI init. And print memory regions is to print F here. All right. Okay. So what you're saying, because I don't actually, could it maybe, I just have a theory. And no, not an IO fucking theory, no, not there. A fucking, what's it called? I can't remember. Okay. Could it maybe have something to do with calls? Or Maybe not. Seems context switching. That's a thing at least. Microphone's too big. Okay, so that didn't give me too much. Scheduling algorithms. Alright, so maybe something here. Random number generator algorithm, yeah, will. Alrighty. So multiprocessor scheduling. Now, do we have multiple processors? Multiprocessing. Multiprocessor documentation. Restricted documents. Okay. Just outright restricted documents. Well, I don't think the normal soul would, a normal human needs to look at that then. x86. How to check? Actually, two things. Maybe I should say OS def x86 64. Not 64 actually, just x86. Check first ECX bits there if. Yeah. Okay, so yeah, we can check it using CPU ID, I guess. That's an AMD CPUs. ACPI. So I guess CPU ID. Yeah, I think we should do CPU ID. Yeah. Okay. Nope. Determine the number of physical cores. Use CPU ID function EAX 0hex 0B. Okay. So we should use that. Now I know from the top of my head, I know that there is a thing. Fuck. That there's a thing called within here, CPU ID, which gives us a lot of macros for different things, and also gives us the actual CPU ID, the CPU ID function. So yeah, let's use that. So when we have So actually, before we init fully, we should do a CPU. Huh? Get CPU ID. No, it's just CPU ID level. So he said 0x0b, I guess it was, and A, B, C, D. A, B, C, and D. I guess that is the CPU IDs. 1, 2, 3, 4. We just make them. We just make them like that. And then we want to check CPU ID. What did you say? You said B there. For Intel CPUs, not there. Could you? Here. Let me see. Is it maybe this? Probably. Was the number of bits to shift right to get next level, and needs to use twice. First time with ECX0, it tells you how many bits of the is used to identify the logic CPU within each core. Logical CPU bits. All right. Did I understand half of that? Nope. So I don't know what this table means, but I guess one thing that we probably could do is to open up this document, which is said to be the Intel CPU ID specifications. That depends on if it actually want to open. They have a save. Do I have some kind of way to extract this already? I've accidentally had this one closed. Oops. 7 7 I need one who is apparently called 0x 0b EAX 0x 0b. Wikipedia. Please tell me anything. Just tell me anything. B. What the fuck is B? Red calls. Oh, that. Blind. Oops, fuck. Smallest monitor line size in bytes. Oh. See. That's that one. We also have a... Huh. We can also check this. Cache levels and there's a few other things here. I don't have a fucking thing. Okay, fuck that. We are going to try. I have a feeling that it should have been in byte form, maybe. What if we do it in byte form? Alright. I don't think as like it can't be fucking like can it? Like my theory was that it could maybe have been more coarse, but don't think that that is it. Because what I would think, at least with Intel, how Intel would do it, is that Intel would do it like extremely convoluted to just do like cores and whatnot. So multi-core architectures. This page is okay. So I don't think that fusion architecture. Okay. Pipelining. Okay, so where did we actually come from? So we have current and then invalid something. Now it happens for the most part within within this function. Now what I'm gonna probably try to do is try to get a UART. Now you might ask, what the fuck is a UART? Well, a UART is a protocol to pretty much transmit data using a serial port. A serial port is good when, let me just grab it. It's good when you have a computer like this one. I don't know if you even can see that. Kind of heavy, so when you have a computer, let me see, is it picking up? Yeah. So when you have a computer with a thing right here, that connector right there can be used for UART purposes. It's a serial port, which then can connect to something else and then get output from real hardware. It's no different than, for example, a screen, for example. Then gets things out in that way. With UART, though, we know everything about it. At least I do. So yeah, you can see it here. Headless console, external logging, networking, and transfer files. And you can, and also for GDB debugging. We have some values here. Now we have some communication ports there. Then now we just need to do something about it. So we can receive from buffer, we can transmit from buffer, enable interrupt enable register, interrupt identification, first in first out control register, line control register, and a bunch of other things. The things that I probably think that we're only going to use is the receive and transmit and interrupt enable. Now, what makes this different than, let's say, for example, E9? I believe it is E9, yeah. Then something like, for example, the E9 port. Well, the E9 port, as much as I at least know, is a way to communicate to, for example, QEMU or Bosch through a serial port. Also, pretty much it's just like a way to like get input in out to a serial port. Now the reason why I want to do UART is because we have in here a serial port where that's not even being used right now. Well, UART port here. How's it going? It's actually going pretty good. I only have some minor errors. And most I only have some minor errors, but yeah. And I am also thinking about actually utilizing a serial port here. Yeah, minor error. This is one error. And also I am also going to do some green screen OS, choose your own UI. No, that's because my shit isn't working. And now I'm thinking of implementing fucking UART to get more information out. Because something fucked is happening with my E6 port. So yeah. Choose your own AI. AI, for fuck's sake. AI has gotten too much in my brain. Also, what if I just make a simpler debug function? There. That literally just like it literally only has a module and a string, and that's it. So it only has a string here. Stir. But I hope that you have also gotten further in your GDT troubles. I do not web onto fuck the module. You can just write the module inside the string, yeah. And then we don't need to do that. Then we can only F. And we need to do F and F, damn it. Anyways, but is it going good with your project too? If I may ask. Oh. Okay, so in the PCI down. Actually, why the fuck did you fuck up? Well, did not like that. Oh, that's why. And why did I say F? Oh, right, yeah, that's why. Yeah. All right. Monitor now is not the time when I need to. I have a monitor as a screen, so I need to like make it not go on standby like a few times a few times an hour. So why are we allocating so much? Like we're malloking like crazy here. it's after kernel start. We have a mode. We found a mode. We've cleared the screen. So it's, yeah, we do have that one. We've done this one. Underscore log debug. Init PCI devices. Frame buffer. So this is as we are doing the VGA. So now we are done doing the VGA. But okay, so it is all in here because of the PCI probe, would I guess. Yeah. Add PC, yeah, it's right there. But the add PCI says the number of devices that there. Okay. Okay. But why are we doing? We're doing two loops. We're probing, and then we have another loop up here. Scan, a PCI scan. That is another loop. Why am I doing two loops? That's pretty much just like the same. We're checking for the vendor, the device, we're printing it out, and then we're making a device out of it. Here we are making a device out of it. We're throwing that in there, and then we can add that device. Pretty much skipping. No shit, the PCI didn't fucking use like a fuck ton of memory. I was wondering why. Oh, now we actually need to get lucky because I figured out that yeah, these errors here, they come whenever the fuck they want. Allocated. This is right after we nearly have, yeah, init device. That's inside of init device, so those errors just come whenever it seems good. Driver support loaded. Great. Bus 5, slot 11, function is 0. Vendor, all that, there. So these are just non-existent PCI devices. Okay. Maybe I should really quickly add a check to the vendor. Actually, we do already have a check for the vendor. Vendor is 11, 1111. Now OS dev had I don't know if they actually do still have that, but they're all PCI vendors where you can check who the fuck is it, pretty much. Now this is apparently some fucked up company, apparently. This is the vendor ID, right? a vendor ID. So what devices do you have? Nothing much. So yeah, you can check, and this is actually a correct one. But whereas of that FFF, that's an illegal vendor ID. So you probably shouldn't just like bring them in. But yeah, like we have on like all of the slots, like all of the slots here, like bus 0 to 31, bus 1 to 31, bus 2 to 31, 3, 4, 5, and we just end at 5 right here, where we have vendor 11, 1111, and everything is actually just 1111, which I don't think is good. So if we do 1111, 1111, I think there's also, I am going to say that if it is, that if the vendor, they should probably also return a ball here actually. That if, right here, that if these two things are equals to 1111 and 1111, no, because then we should also then check for if PCI device dot bus, not bus, the vendor ID is equals to 1111 and that one, and then we can then skip it. For the rest of these, return true. Audio processor, ISA, others, and so on and so forth. You can go down and then just like do all these. I don't want to do that, at least not yet. And then else, if anything fails, then just return false. Why do you want to do that? Oh my god, I need to write a lot of helper functions to do this non in a painful way. Yeah, like if I just check here, these are some of the helper functions that I have for the PCI. And everything correlates back to read D word, or write read D word, read word, write D word, and actually I don't even have write word. Huh. Do you even use this one then? Oh yeah, I do. So yeah, everything you need to make a lot of helper functions to do PCI shit. And that is because this one also needs to be changed to Boolean. But yeah, for the PCI, especially for the PCI functions, you need to have a lot of helper functions. You don't want to do it alone and yourself only. Init devices. Hey, we got one from vendor 11, 1111 and 1111. Holy shit. My favorite vendor ever. Shit, man. Why does those fucking all over the place? Scan PCI devices. Like, if you wanna, like, there's generally many things that you need to do. Write helper functions for. One of those being, of course, the PCI, as already said. Oh shit. Oh shit, what? To this? But there's also some other things that I, for example, have written helper functions for, which probably makes more sense. For example, fat functions. This is just a casual 1166 line document, a line code file, just like that. Like, yeah. And that's helper functions and whatnot. So write them, for fuck's sake. If you don't already like write the helper functions, then begin to do so. Init PCI devices. I have a feeling that did not that uncommented this one. I was damn fucking correct. Trying to enter 32-bit mode. Do you want to hear the worst part? But my emulator is fucking dying. Like, do you want to hear the worst part of everything? Of 32-bit mode dying, right? That's the easiest part. And how the fuck can it rain in Denmark so fucking much? Holy shit! But yeah, entering 32-bit mode is one of the easiest things, easier things that you're ever going to do. Right there, right here, just like that. Enable the 820 line, sorry. Load a temporary GDT for your bootloader, and flip 1 bit. And of course, just jump real quick. That is the easiest thing that you're gonna do, and that is the only easy thing that you're gonna do. But if, like, what emulator are you doing? Are you using? Because even on my fucking school laptop, I can run an emulator. So either your fucking PC's QEMU. Huh. That's probably a PC's that's fucking dying. Because I could fucking also run emulators on that one. I'm entering 32-bit mode wrong. Wait, what? Set that there. Okay, that's there, yeah. Scanning PCI devices to PCI devices, allocating a fuck ton. Allocating up a fucking storm. Maybe if it is false, I should probably then save. Read that one. Probably. At least it's a runtime error. I guess that's the point where I'm actually having to make functions separately. Yeah. I don't see, so reallocated. I hope that we're just reallocating over and 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 over again. So we're allocating first, and then we're reallocating. Shit. Why the fuck is it? It's just stopping doing shit. We're allocating to the same thing, and then it's just like saying, hey, you are trying to read from this address, don't do that. Don't do that. For fuck's sake, I'm not even near that address. It can't be the paging, can it? Segfault? Maybe. Okay, so where could it go wrong? It go wrong in the in bytes, in out bytes. In bytes, it could go wrong in the malloc. Which, wait, two things. Where is it actually throwing it? Why is it saying that it has an error? It says it hasn't. It says it whilst it is writing this, which means it is in the malloc function right here. Right, this function. If I comment that out, like, you can see that in two ways with segfault, because you can't really segfault if you don't have an operating system. Or it's at least pretty hard to do when your kernel is barely working. Why is it just like throwing that one out there? It could be because of interrupts. What if when we scan, I disable interrupts, I scan and then enable them again? We at least got some text. Not a lot, but it's some. Actually, it is pretty much a lot. And one way I can actually check if it is something to do with interrupts is by just like making a key loop there. Let's see. So what do we got? We got there. Press any key. Invalid read address. Is it? I am more and more thinking that's because of a call. That's literally just because of a call that's like just decided to run. But it wouldn't make sense that it's a call because I'm not even using calls. Let me see. Because it can't be because of I don't think it's because of calls and threads. It wouldn't make sense that's calls and threads. You calls what's it called process? Running by the how to activate secondary processes. In the Intel manuals. Is this the one? Multiple call. You got something. System config. So this thing in sysconfig. I guess they just something kind of like do I have some function that's like it? No, but the MP can use it. Right, that's probably pretty much also just some like what's this thing? Let me actually just OSF startup. CPU box. Maybe it could be something like CPU box. Nope. No select the loading. Extended page table. A move to there when apt is enabled may lead to an unexpected seg folder or an incorrect page translation. Maybe that could be it. Maybe that could be it. Incorrect page translation, because it's all happened. If I go into paging here, right, I just don't enable paging, I would bet that everything will be running. A whole bunch of unhandled IRQs. But yeah. From PCI? Huh? Unable to mount on queue. Oh shit. There. So this is from the PCI. PIC. Next time, maybe read. Thing is, it was unhandled IRQ module PCI, yeah. But in the IRQ, yeah, that makes sense. That's because of the pits. What the fuck is the pit? Pit. Brad Pitt. Right, there. And if we enable this one again, so it has something to do with paging. It has something to do with paging. Some kind of paging translation, I would guess. Why is there no? Okay, this thing is, why the fuck can't you unable to mount /ATA0 on queue? Why are you trying to mount that one on queue? I thought that was just a spider there, fuck. Unable to mount /ATA on S, which is the name, which is the device name. And then we get the device ID. What is the device ID? That's 0. The device is there. So something is both happening in the ATA driver. Probably. Alright. I should have goddamn fucking used SATA instead. At this point, I just want to go over to my, come down to my shell. At this point, I just want to go down to my shell right now. So it has something to do with paging. That much we can get out of this. It happens whenever the fuck it wants to, I guess. And yeah. Why? Let me actually make a paging.asm file. Paging underscore asm ms ma. Good morning. And then let me then just have global function here. We need to define it as a void there to avoid with a void pointer to the page directory location. That means that we need to set up the stack and a frame. Okay, so we wanna set up a frame that's EBP. Then wanna move there. Then we need to save some registers, for example, EAX and EBX. Those are probably the only two that we need. Actually, maybe even also only EAX. Then in the EAX, we want to load EBP plus. Is it plus 8 for the first one? It isn't. It is. Then we want to load that into there. Then we want to get that one, or it, and there. Pop EAX, pop EBP, return. Now what it then also should do is to... Do I actually really need to do that? I don't think I need to do that. I didn't enable it. I didn't uncomment it. It's still the fucking same. So now we should see external void there. All right. Boot looping. There we're mapping, and then we are losing on one of these. And it is the exact same shit. It is because that we didn't do this. Actually, also it only needs to be a U32. Right there. Looping once more, and again it's the same shit. Though this time we actually do have I remember that there's another bit that you can sit in here in one of the control registers. Multiple processor knob there. None right through. Right protect. Okay. Is that maybe on by default? able to use that instruction. Interrupt pending. Other things. Page level. Page level cache disable. Page directory base residual. That's mouthful. Okay. Do you also? Okay, let us. Let us really quickly place a breakpoint here. Focus CMD lay out next and continue. I'll do next here again, and then we want to check the. Why is the borders fucked? Now I want to be able to check the control registers. Yeah, I'm sorry you guys can't see too much again. I hope it's good enough. Okay. Let's see. Right down. It's 400000. That is correct. And now as soon as I press enter again, it will boot loop. Not that enter. Alright. ET, what the fuck did ET mean? And then ET extension type. Don't know what that means. Very good. Get that. Flip that bit. And I will guess that this is where then it will be fucked. Pop that down. I was about to get my hopes up. Okay, CD. Cache disabled. It just disables the cache. Right there. Just says nope, fuck this. I'm out. So yeah. Something fucked is happening. I do not know what. Let's keep this implementation. It worked. It at least kind of worked more than my assembly solution. I don't know why. Though it gives a fuck ton of read-write errors. I'll have to investigate on why this is. Because I don't know why. One thing is, if I really quickly just like do this. Actually, 2 seconds. When we have this one up, then we pretty much can't use the pit. Alright, this is probably also going to be last command of the day because I am tired, I didn't sleep well, and yeah. Focus, CMD, delay, next. And then we wanna go to breakpoint, kernel start, continue. Next line. It fucked up there. What address are we on? Oh, fucking. Code segment 8. ET and MP. Monitor coprocessor. And ET extension type. Hey, at least this one is good. Okay, I don't know why this is. I'll have to investigate. But yeah, I think that was it for the day. I'm tired. Damn, I'm tired. So yeah, that was it for the day. See you all next time tomorrow, I would say. And yeah, see you all there. Goodbye.